In this section, we're going to talk about what's known as conditional probability. So first, let's do a little bit of a review here. In a sample space S with equally likely outcomes, the probability of an event E is simply what? What is the probability of the event E? Well, a couple of ways to look at it, but one of them is just use the formula. Remember what an event is? An event E means that E is a subset of the set S. So the total number of possible outcomes, we would say, is the number of elements in the sample space. That's our denominator, and the number of elements in the set E would be our numerator. So we've done this many times. For example, if you had S being 1 through 6, like the experiment was simply rolling a die, that's all the possible outcomes. If our event were the probability that, let's say it's 5 or 6, that means this event occurs if we roll a 5 or a 6. The probability of E would simply be the number of elements in E over the number of elements in S, which is 2 over 6, or 1/3. So 1/3 of the time you're going to roll either a 5 or a 6. All right, well, here's where conditional probability comes in. What if you're given some new information that might actually change that probability? This time, let's suppose I draw a card from a 52-card standard deck of cards. Only I look at it. You don't know what it is. What is the probability that I drew a diamond? Well, I'm being a little informal here. I'm going to call capital D the event that it's a diamond. So remember that there are 13 diamonds in the deck. There are 13 hearts, then 13 spades and 13 clubs. So the probability that I drew a diamond would be the number of elements in D, how many diamonds there are, over the number of elements in the sample space. For this one, what's a sample space? If we're drawing one card from a 52-card deck, there are 52 possible outcomes. So the probability would be 13 over 52, which reduces to 1/4, which makes sense. There are 4 suits in the deck, and they all have the same number of there's all 13 of each of the suits. And one of those 4 suits is diamonds. So anyways, this does make sense. All right, so now let's bring conditional in this same example. Suppose now I give you the information, I draw the card, and I tell you the card is red. Now what is the probability that the card is a diamond? Well, things have changed. When I tell you that the card is red, and you want to know the probability that it's a diamond, well, how many red cards are there? There are only 26 red cards, so it effectively changed the size of my sample space. We're ignoring all the black cards for this one. So there are still 13 diamonds, so now the probability has changed from 1/4 to 1/2. So this is called the conditional probability that the card is a diamond, given that the card is red. And here's the way we denote it. So in this example, the probability of the event D, given that the event R already occurred, in other words, I told you it was a red card, that's equal to 1/2. So this is the same D, that it's a diamond, as up here. So with no information given, the probability was 1/4 that it's going to be a diamond. With the additional information that the card is red, it changed to 1/2. All right, let's look at another simple problem. On a multiple choice exam, the first question has 4 choices, A, B, C, or D. You have no idea which the correct answer is. You know nothing, so you're going to randomly guess. Then you're just going to guess a D. Well, what's the probability that you guessed correctly? well, it would be the number of, it's going to be 1 out of 4. Basically, your sample space is going to be A, B, C, D. Those are the possible outcomes. And you're guessing this outcome, this D, which is just one outcome. So 1 out of 4 times you're going to guess correctly. Now, suppose you read all of the answers and you know that option B is not the correct answer. So you're really now guessing among among A, C, D. Now you know it's one of these, but you don't know which one it is. So you're going to guess among these 3. So now the probability that you guessed correctly is going to be 1 over 3. So based upon some information, in this case the new information was you know that B is not the correct answer, the probability is changed. Well, we'll eventually get in another video a formula for determining conditional probability. A formula for this statement right here, the probability of D given that R occurred.